hope and pray a little bit for a rainy snow day. So what we got today? We're going to do the exploration, everybody's favorite assignment, the exploration for sedimentary rocks. So if you go on to Discovery Education, you notice that the only thing assigned is the reading. So everybody get on, click on the reading, and let's go through this together. It takes you to the sedimentary rock section, which is on the Explore tab. So all you need to do is scroll up just a little bit and click on Explore More Resources. Once you get to that page, scroll all the way down to the bottom, and you will see today's assignment, Exploration Sedimentary Rocks in the little green picture there. That's what we're looking for. So as I get started on this, if anybody has any trouble getting to the assignment or seeing it or seeing the reading, just let me know and I'll come back and get you fixed up. But I'm going to move forward with this. And also remember, if you get behind or you want to catch up on something, I still post these videos on the Google Classroom. So, if you got a little distracted, didn't get your assignment done and would like to do it later or the next day, hop on, look at that video, and you can always get back on these explorations and do them. As long as I haven't already put the grades in the grade book, you should be good. So what we're doing today is sedimentary rocks. They've got a little introduction where they explain what's going on. We have 9 different sedimentary rocks here. These are pretty regular straight-up rocks. We got some conglomerate. We've got limestone, sandstone, coquina, shale, coal, rock gypsum, travertine, rock salt, all different types of sedimentary rocks. And they want us to classify them. So let's see what we need to do. We need to select a rock. We'll start with a conglomerate, and we will classify it. So they show you a picture of it. This is not the greatest picture, but basically it's a rock that looks like it has big chunks of other rocks inside of it. So I'm seeing like these round circles here. These look like river rocks, like you would see in a nice mountain stream. And so the question is, what is the texture of this rock? I'm going to say very large rounded pebbles with smaller grains in between. That's probably a really good way to describe this. So I hit submit, and it tells me that's right. Yes, next. Does this rock contain visible fossils? I don't see any visible fossils, so I'm going to say no. Submit. That is correct. Next. And then third question of this rock, does the rock fizz when a drop of HCl is put on it? I'm going to take my hydrochloric acid dropper and click on it, and it's going to drip the acid on there, and we'll see, does it bubble or fizz? It doesn't look like it does, so I'm going to say no to that. Although that was entirely possible. Could have been a thing. That's right. What's next? Warm water test. Do you think this rock will dissolve quickly in warm fresh water? That's going to be a no-go. I don't even have to test it, but yeah, it's not going to dissolve in water. No. So, submit. Yes, that's correct. Scratch. There's a lot of stuff to do on these. Scratch for hardness. What are we doing here? Oh, we got to select. Does the fingernail scratch it? No, my fingernail's not going to scratch it. Does a penny scratch it? No, a penny's not going to scratch this. Do the penny. I need to hurry up. Penny did not scratch. Does a knife scratch it? I'm thinking a knife is going to scratch this, yes. What do they say? If I had to guess. No scratches with the knife. So then is the glass going to scratch it? And I would say yeah to that. Come on. Surely it's going to scratch it. No scratch on that. So it's got to be pretty hard. What is the main mineral's hardness on the Mohs scale? Not scratched by any. So it's going to be the hardest one. That's right. I know it's right because I just watched it happen. Where is this rock found? So this is actually going to be a little bit more difficult because it's hard to see what these pictures are. Does anybody see like a river? What are these things? Can I pick any of these? Oh, all right. They just have them described over here. So Where is this rock found? A conglomerate's going to be found near a river. Inside a cave, no. In an old lake bed, no. In a very thin, dark layer between layers of sandstone and shale, that could be it. In a place with lots of caves and sinkholes, nah. In a thick, flat layer exposed on a deep canyon wall, that could be it. So I think it's going to be either one of those, not coastal areas. So I'm going to start. I don't think it's. No, thin, dark layer. No, it's not the thin, dark layer. So I'm going to say a thick, flat layer exposed on a deep canyon wall. And that was right. So now, after we've gone through all that, we have classified it, or we need to do the last classification. This one's going to be clastic. It looks like it's made up of pieces of other types of rocks. And so it's going to fit in the clastic category. Let's see. I have to go back and select another rock. That's a lot of stuff to answer for each of these rock samples. That's a lot of stuff to do. The texture of the rock. Am I going to go through and do all this? Visible fossils? No visible fossils.
Give us show me OB faster.
Oh, does it just show you all of it? Well, then I don't have to select it. Well, that's not very nice, though. That's lazy. Oh, how terribly lazy. We shouldn't do that. And then this is going to be a classic rock. And then we're sorted. Let's see if we can do the questions without this. Let's just see. So how many questions do we have in this one? 9 questions. Is there a second page? No second page. Wonderful. I hate second pages. So 9 questions. Let's see if we can go through these without doing the entire lab. Or maybe we'll just do the ones we need to. So question number 1. A geologist compares an area showing ripple marks preserved in sedimentary rocks with an area showing the presence of mud cracks preserved in sedimentary rocks. Explain what he or she will conclude about the environments for these 2 regions. So I got 2 things that I'm looking at in the rocks. I got ripples and I got mud cracks. First off, does everybody know what mud cracks are?
Yes.
What are mud cracks?
Cracks in the dirt.
Yeah, but why do they happen? When do they happen?
When it's dry.
Yeah, but it's not just when it was dry. It had to be wet before it got dry.
Wet.
Yes, and so it's mud that gets
Dry.
wet and then dry. Mud cracks form when I have this like wet, dry environment. So it's got to be wet first, and then it has to dry out. And then as it dries out, your mud starts to get the cracks forming in it. And so if I find a fossil that has mud cracks in it, I know it was an area that did get wet. It wasn't dry all the time. And then eventually it dried out and the mud cracks came in. But what about ripple marks? If you had to guess what a ripple mark's going to be. And basically this is like a rock that has, well, that's not a great drawing. It has little like almost ripples like this. So I don't know if you can kind of see this very well. I don't know. Does that make sense? So this is like from the side. It has like little ripples, almost like little waves. And so let's see if I can find a picture. Maybe if I show you all a picture, y'all be like, yeah, that's what that is. Let's see. Ripple marks. Yeah, like this stuff. Like that.
Oh,
Like
yeah,
that?
I've seen
Like that. So what do those ripple marks cause? Like where would you expect to see that?
Sand.
Sand?
Desert.
A little bit, but no. I mean, you're gonna see some of this in the desert.
The wind. Like
Yeah, the wind, but when the wind blows, you're not gonna get you're gonna get some of this, but most of it's not gonna look like that. It's gonna build up into big sand dunes out in the desert.
Yeah.
These ripple marks are caused by flowing water.
Yeah.
So the wind blowing sand looks a little bit different than ripple marks. Ripple marks are caused by flowing water. You can kind of see it here. This is partially underwater. Trying to see if I can find some better pictures of it actually forming. Yeah, I think that'll be good enough. Yeah, you gotta have some sort of current. You gotta have some sort of water pushing these around. Where your wind is probably gonna build up something a little bit bigger, like a sand dune kind of size. Not that you can't get them with just wind, but they're more commonly associated with water. So when they're asking me the question, what's the difference between a rock? So he finds a rock, shows the presence of mud cracks, and one that shows the presence of ripple marks. Explain what he or she will conclude about the environments for these two regions. So what I'm thinking is the ripple mark stuff is going to be a area that was mostly underwater. Probably shallow water, because if it's deep water, I'm not going to get the waves that kind of cause those ripple marks. So it's going to be some sort of shallow river or shallow lake, where the place that has mud cracks, you're not going to see any mud cracks like underwater. That's not a thing that happens. And so I know the mud cracks was probably a field that experienced wet and dry conditions instead of all wet. So ripple marks, I'm thinking like a lake or a shallow stream. Where mud cracks, I'm thinking more of like an open field, but not necessarily dry all the time. It's like dry and wet environment. I guess we'll see. Number 2, explain the term lithification. What 2 major processes are involved in lithification? We're going to go back to the text for that because I know that's probably right up at the top. So lithification, the term lith or lithos refers to rock. And so lithification is almost like rockification. This is how you create a rock. And the definition should be right up here near the top somewhere. Oh wait, I'm on the wrong page. Explore page. You going? It's not going. So go over to the Explore page, and lithification is going to be somewhere near the top. They start to talk about it in this chapter, but they don't actually give you the term, do they? Surely it's in that paragraph right there. Weathering, wind, cementation. In addition, you have compaction. Together, cementation and compaction form sedimentary rock. That is lithification. Like that's what lithification is. And so when they ask about lithification, it's got to be in here somewhere with the actual term.
You're still looking up?
You could just do a search at the top of the page and see what they give you as far as, so classic sedimentary rocks, they talk about it in here. Well, now I'm interested. It's in that first paragraph. I'm just interested if they even say the word lithification. Because I don't think that Discovery Education is a very good book. I'm just saying it out loud. We're all thinking it. Lithification. Oh, it's not going to search the page. Let me go back and search the page.
Just do
Edit. By. Wow, that's pretty interesting. Not on the page. Litify. A couple of That's it. Okay, fine. So we're gonna have to define this ourselves because that's not really good. So explain the term lithification. That's just the creating of a new sedimentary rock. Lithos means rock, and ification means I'm doing something. So you're basically creating a rock here. Lithification is the creation of the rock. What are the two major processes involved in lithification? Those two major processes are these two down here, compaction and cementation. So give me a little bit about each of those, compaction, cementation, and how those two things together are how you create a sedimentary rock, which is the term lithification, which they should have had in the text highlighted so you know what the term lithification means. Just saying. Number 3, how can you tell the difference between a conglomerate and a breccia? What does this difference tell you about the origin of these rocks? Okay, this is actually something we go over quite a bit in dual credit geology. And so they don't have a breccia up here, but they do have a conglomerate. And I just want to think about the names. This is probably not going to go like I want it to go. What's the term conglomerate mean? Where have you heard the term conglomerate? You've heard it somewhere.
No.
Who's heard the term conglomerate? No?
He hasn't heard about it.
No one's heard the term conglomerate ever?
No.
Not in business. Who's taking business class? Yeah. Think about business class. No?
Who's our business class teacher? Is it Rob?
Never heard the term conglomerate. So in business terms, a conglomerate is a really big company that owns lots of other little companies. And so yeah, you've heard the term. And so like an example would be like Apple. Apple owns all sorts of other smaller companies that do all sorts of things that Apple doesn't do. Disney would be another one. Google would be another one. These are all conglomerations. And so a conglomerate in business, is a business that's like a collection of other businesses. So in geology, it's a rock that's made up of other smaller pieces of rock. So rock made up of other rocks. Now, breccia, which is going to be very similar. They're almost exactly the same. They just have one kind of difference. And in my brain, I already know the connection to this, so my brain knows what to say. But if you look at this word breccia, think of, I don't know that this is true, but think of like this being an Italian kind of word. If you think of breccia as like an Italian word in your brain, what do you think that breccia might be? No, but that's okay. What were you saying back there? Brecciated? Did you say that? I wasn't talking to you. You didn't say it, did you? No. Does anybody have any guesses? It's okay if you don't get it. To me, the word breccia, my voice messed up. Always makes me think of like broken. And that's literally, if you type in the word breccia, I believe in whatever root language it comes from, it means broken. And so the main difference between these rocks is in breccia, the pieces are very angular and sharp. They look like they just got broken. In a conglomerate, the pieces are all very rounded, and they're kind of put together like that. So these look like more like river rocks. And in breccia, they're all kind of broken up a little bit and have very angular sides and look kind of very sharp, almost like broken pieces of glass. And so what does that tell us about these two rocks? If you think about it in like a formation and movement kind of thing, if a big boulder like this were to roll down a hill, what would happen to it? What happens to rocks as they kind of move further away from where they're going? Yeah, it's going to weather. And literally it's going to weather. The more it moves, the more wind pushes it and water pushes it, and the further it gets away from where it actually broke off of its original rock. These corners are going to get rounded, and it's just going to get more and more kind of like round. Round is what everything wants to go to. So if I have rocks that are freshly broken and I can see all the sharp angles and all the sharp edges, I know that that rock didn't travel very far. It broke somewhere like right around here. If I have a rock that's nice and rounded, like a smooth river rock or something, I know this rock has traveled a really far away from its original point that it broke off of. Because it's tumbled and rolled, all the corners have gotten knocked off, it's gotten weathered and eroded a little bit. And so these are very similar rocks. They look exactly the same, but the breccia has sharper pieces, which tells me that it hasn't traveled very far from where it originally formed. And that's kind of what they're asking you. What does the difference tell you about the origin of these rocks? The breccia is going to be closer to where it originally formed. The conglomerate is going to be found further away from where it originally formed because all the pieces are rounded and it's been weathered and eroded for a longer time. So breccia is going to be found closer to where it originally formed. The conglomerate is going to be found further away from where it originally formed because of the roundness of the pieces. Okay, so explain the process of the formation of sedimentary rocks. So I need to create some sedimentary rocks. And I want to explain that process. And what I'm looking for is 4 different things. Maybe a 5th in there. We'll see how we go. So I don't have a sedimentary rock. I don't have it. It's not there. It doesn't exist. What's the first thing I need to do to make a sedimentary rock? What do I have to have? I got to have sediments. And in order to get sediments, what has to happen to break a rock down into sediments? Yeah, weathering and erosion. So step 1, I got to have that weathering and erosion. And that's going to create my sediments. Weathering and erosion creates sediments. Step 2, those sediments have to go somewhere. They have to stop moving. They have to stop being eroded or pushed down the stream or wherever they're going to go. And the term we use for when sediments stop moving, we call that deposition. Just like a deposit. Like when I deposit my money in a bank, it stops moving. It doesn't move with me. It doesn't go here or there. It's in one place. It's deposited. It's nice and safe. So sediments, we call the same thing. When they get out of the river, when they settle down in a field or wherever they happen to stop at, we call that deposition. So deposition is step 2. Now I have my sediments. They're in one place. Now I can start to make a rock out of them. The next thing I need compaction. Anybody ever build a sandcastle?
No.
Those of you that did build a sandcastle, you just like scoop loose sand into your bucket and then just flip it over. You gotta like pack it in there, right? Because if you don't pack it, it's not gonna stay together. Same thing with like a snowball. We don't get snowballs here ever, but if there was snow, or if you come from a different part of the country that has snow, you don't just like scoop up a hand of snow and just throw it and expect it to stay together. To get a snowball, you gotta get the pack going.
It's supposed to snow on Monday.
No,
I don't
it's
think
not.
it will.
What, on Monday? Nah, I've heard Wednesday night. And not snow, just like a wintry mix.
No, it's Monday, yeah.
Listen,
Looked at the weather
listen.
today.
You have lived here your whole life. You're saying this in a classroom full of students who have had their dreams dashed every year. They're like, oh, it's supposed to snow. Oh, it's supposed to snow. It's been years since it snowed like any reasonable amount. We don't believe you. We don't believe you. Sorry, we don't. No, we don't. He's just saying that. He doesn't believe you.
It snowed like 3 weeks ago. Just snowed.
It barely snowed. Did we get a snow day? No, we barely got a late arrival at 10:15. It wasn't that great. It wasn't that great. I need snow days. I need snowballs. It was not good. But we can all agree to throw snowball, you gotta compact it, right?
Yeah.
So to make a sedimentary rock, I need compaction. And then I've taken my sand from my sand castle and I've compacted it and I've made a nice little like a tower or whatever I'm making for my sand castle. Is it now as hard as a rock? No. So what's the last thing I need to keep all my sand together and make it like a solid rock that's not just gonna fall apart? Heat. Not heat. Well, because heat, then you're getting into metamorphic or igneous rock. And so the last thing that holds it all together, this is called cementation. So literally like I'm cementing something or gluing it. Cementation is the last little part. And compaction and cementation were part of your answers for number 2, I believe. What is the parts of lithification? These two right here are your lithification. So those compaction and cementation, that's what's actually going to make your rock. But the whole process for making a sedimentary rock, I gotta have weathering and erosion. I gotta have deposition. And then I can compact it by putting other sediments on top. And then I have some sort of water flow through with quartz or calcium carbonate. And it's gonna like glue in a way, glue all the little pieces of sand together. So now instead of just loose sand, I now have a sandstone or sedimentary rock. So that's your process of formation of sedimentary rocks. Weathering and erosion, deposition, compaction, and cementation. I couldn't see those from over here. So, number 5, explain how igneous rocks are formed from sedimentary rocks. How's any igneous rock formed? Like, what has to happen for igneous rocks to form? Yeah, it's got to be melted down into magma. It could eventually become lava, but it's got to be melted down into magma. And so how is an igneous rock formed from sedimentary rock? It's got to have subduction. It's got to be pushed down underground and heated up to the point where it's melted. Then it will become an igneous rock. So it's got to be subducted or pushed down underground, and it's got to be heated up to the point that it's melted. Then you'll have an igneous rock. Number 6, explain the sedimentary structures, cross stratification, and graded bedding. So we've got 2 terms here, and I want to show you what both of them look like so you can kind of explain them. The first one is called cross stratification. This is going to be features shown by wind blowing. And I'll let you just Google it here. So does the wind always blow in the same direction?
No. Sir.
So cross stratification is basically the evidence of that. What you see in here, let's see, can we make this bigger? Not really. That's cross stratification. This is cross stratification. These kind of weird lines that go back and forth in a way. Here's a different picture of it.
So it's ripple marks, but like.
Well, but no, it's not ripple marks because it's not caused by water. It is almost like dune plains caused by wind blowing. And let me see if I can show you how this works. That's pretty close to it. Yeah, let me just see if I can draw it on the board real quick because there's not a lot of good images here.
So wait, why can't sand get
Huh?
like in the desert? Why can't sand get packed down into rocks? Because there's no like water and stuff. You know what I mean? Like
No, your desert sand can get compacted into rocks. But yes, there's not a lot of water there, and so it's lacking that last part, which is cementation. Doesn't mean it can't happen. And just because there's not water at the surface in a desert doesn't mean there's not water below. So there are still plenty of rocks getting cemented in the desert, but it's not as common in other places because of that lack of water. And cementation, you got to have some sort of water that's bringing the minerals in to kind of cement everything together. So yes, that's mostly the reason. But it does happen just deeper underground where you still have access to water. For the ripple marks, let me just kind of show you what you get instead of ripple marks for blowing wind, because the ripple marks happen in water. What happens when wind blows like some sand around? what you get is dunes. You get like a dune structure. Even if they're smaller, it's called a dune structure. And basically, your wind blows. Let's say the wind blows this direction first. It's gonna push up this like slightly inclined hill, and then at the end of the hill, it's just gonna kind of fall off. And so every little bit of sand that gets pushed up this hill by the wind, it's gonna fall down this backside and basically start to pile up. And so I'm gonna have a pile up of sand kind of off the backside here. I'm gonna have another pile up of sand off the backside here. And basically as these little pile ups happen, I get these lines that kind of build outward. And so if I cut my dune in half, what I get is a whole bunch of these little lines that come back out. Does everybody see that? Now, this all happens with the wind blowing one direction, but does the wind always blow the same direction? No. And so what happens is the wind blows back the other direction, and I'm going to get another dune kind of set on top of this that has these opposite lines kind of built up. So I'm going to have this kind of like opposing dune here that comes back out this way. And what you get is you get this buildup of these dunes on top of each other over and over and over again in different layers. That is your cross stratification. And that's what we're seeing here. They're kind of showing you get them built up. This is kind of a big one, but you can see the layers coming down this way, and then you see these layers coming down this way. And then you see another layer kind of on top coming the other way. That's what they're looking at with this cross stratification. So with that, explain sedimentary structures, cross stratification, and graded bedding. Okay, so cross stratification. This is, I would explain it this way. Sand dune features caused by wind blowing in different directions throughout a year or throughout a period of time. It doesn't have to be a year. But cross stratification is sand dune features that alternate back and forth because the wind changes direction. That's the way I would put it. Sand dune features that alternate back and forth because the wind is changing direction. Where graded bedding I think I kind of showed y'all this the other day just before we left. Graded bedding is when I have a stream that flows at different rates during the year. So when the stream is flowing fast, it picks up all the big stuff. So like right after it rains, all the big material gets picked up. And then as soon as it stops raining and the river slows down a little bit, all your big stuff gets dropped out into the bottom of the riverbed. So I get all my big stuff laid down here in the bottom. And then you go a couple more weeks without any rain and the river slows down to like just a trickle. And then all my medium stuff comes out on the bottom here, just a little bit smaller than my big stuff. I probably should have made these a little bit smaller, but all my medium stuff comes out. And then at the very end, when the river's about to go dry, only the finest little dirt particles are left, like floating around in the water. It drops all my really small stuff at the end. And then my river's dry. And it's going to be dry until when? The next time it rains. And the next time it rains, it's going to fill all the way up because it rains a bunch. It's going to pick up all the big stuff again. And it's going to start to drop big stuff back on top over here. And so what you get is this cycle from big to medium to small, then back to big to medium to small. And this is your graded bedding. I'm going to go big, then medium again. I'm not going to draw all that. Little medium ones. And then another layer of small ones. And so that's what graded bedding is. Graded bedding is sorting based on seasonal changes of water flow in a creek or stream. Sorting based on seasonal changes of water flow in a creek or stream. So I get layers of large pieces of sediment, medium pieces of sediment, and then small pieces of sediment alternating over and over again. Small, medium, large, small, medium, large. Okay, explain the formation of limestone in caves. This is going to be very similar to what they're asking about with stalactites and stalagmites. So how do stalactites and stalagmites form? What do you need for a stalactite and stalagmite to form? Water. And what's the water doing?
Moving.
It's moving, but specifically where do stalactites and stalagmites happen in a cave? Yeah, it drips from the top, right? So it drips out of the top of the cave, and it leaves this like spike of rock, and then it drips on the bottom, which the spike of rock grows from the bottom. If just water dripping, where does the rock come from? Where does the stalactite or the stalagmite come from?
Sediment
Yeah, but where is the sediment in the water?
in the cracks of the rock.
Well, it's not in the cracks because there is no rock there when it starts. So like I have my cave. Right, so I got rock above, I got my cave, that's the top, here's the bottom. I got rock all down here, rock all up here, and I have water start to drip from like a crack in the rock. And the water just drips out. And eventually, I form this little stalactite, and it just grows from the ceiling of the cave, and I form this little stalagmite, and it grows from the floor of the cave. Where does the rock come from that makes those stalactites and stalagmites? Because all I'm having is water drip through here. So doesn't the rock kind of have to come from the water?
Yeah.
See, you can't have rock like squeeze out of a crack.
But wouldn't it
There's no
technically
sediments
be
coming,
sediment?
huh?
Wouldn't that technically be sediment?
It's not sediments though. There's no pieces of rock that's coming from. It's not like I have a hole up here that my stalagmite's like coming from.
Then how does it grow?
So what it is, it's dissolved. In the same way, like if I have water evaporate from,
Salt water?
yeah, but if I evaporate all the water out, what's left? Salt. But was there solid salt before? No, so it was dissolved. And that's what they're getting at with the formation of limestone in caves it plays right into the stalactite stalagmite thing. The rock is dissolved. The mineral is dissolved in the water. And then as the water flows through the cave, or in the case of stalactites or stalagmites, as it drips from the ceiling down onto the floor, some of just a little bit at a time of that mineral undissolves essentially. Trying to think of the word. Now I can't think of it. But anyways, it comes out of solution and does the opposite of dissolving. It's coming out of solution. There's a term for it, but I can't think of it right now. And it solidifies against the cave walls. And over time, the more water flows through, the more it just builds up that layer of limestone or whatever it happens to be for your stalactite or stalagmite or inside the cave. And so explain the formation of limestone in caves. The limestone gets dissolved somewhere else. And so the water that comes into the cave has dissolved limestone in it. And that limestone gets essentially deposited. We already used that term over there. It gets deposited in the cave. So the water that enters into the cave already has dissolved limestone inside of it. And as it goes through the cave, it deposits that limestone inside the cave, kind of adding to the inside of the cave.
Can we submit?
If you're done, you got answers for everything.
Oh, we have two.
Don't need my answers. What, you got 2 minutes? We can get this. Name 2 sedimentary rocks formed by the process of evaporation. What type of sedimentary rocks are evaporites? Gypsum and rock salt are 2 sedimentary rocks formed by evaporation. Gypsum and rock salt. Explain the different textures of sedimentary rocks based on grain size with an example for each. You can do shale. Shale's a small grain size. Sandstone or conglomerate would be a medium or large grain size. You can find those in the reading. That should get everybody most of the way through. If you have any questions, send me an email. If you need any help, let me know. Make sure you submit when you get all your answers in so I can get it graded. Thank you and have a nice day.